Hey guys, this is CPM 2, Module 1, Lesson 2. And so this is a lesson on Intro to Variables, Algebraic Expressions, and Equations. So let's jump right in. Objective A, evaluate algebraic expressions given replacement values. So before we kind of get into this, we got to go over some vocab. It says a symbol used to represent a number. This is called a variable. A lot of times we'll see that variable but to be x, but it's not always going to be. So any letter will work. And a combination of operations on letters or variables and numbers is called an algebraic expression or simply an expression. The technical term is algebraic expression, but more times than not you'll just see it referred to as an expression. And so we have a couple of examples of some expressions here. Notice it says a combination of operations. So that means multiply, that means divide, add, subtract, anything like that. And so you've got 3 plus x, 5 times y, or even a combination here of a multiplication, subtraction, and addition. So those are all examples of expressions. Now, a lot of times when we see multiplication, up until this point, we've used this little dot to let you know things are being multiplied. So 5 times y. Kind of from now on, if we see no operation sign between them, this operation is going to be understood to be multiplication. Okay, and so that's what it's saying. If two variables or a number and a variable are next to each other with no operation sign between them, the operation is multiplication. So we've seen this right here, 5 in parentheses 4. That simply means 5 times 4. When I see something like 2x, again, that's right here. That's a number and a variable next to each other. That means 2 times x. And when I see xy or x in parentheses y, that is your two variables right next to each other. That does mean x times y. So from now on, if we see nothing in between it, just two things right next to each other, that is known to be multiplication. So right here it says an algebraic expression such as 3x have different values depending on replacement values for x. So for example, if we say x is 2, that's supposed to be then instead of 10. Then 3x becomes 3 times 2, so your answer here is 6. But if we say x is 7 instead, now that's 3 times 7, now my answer is 21. And so it doesn't matter when an expression what you plug in for x. You can plug in any number that you want, and you're more times than not always going to get a different answer, but there's not one right or one wrong thing to plug in there. And so down here, replacing a variable in expression by a number, then finding the value of the expression, that is called evaluating the expression. And a lot of times you'll just see this word here, evaluate. So let's go to the next page. So evaluate. We are evaluating xyz plus 6 if x is 4, y is 2, and z is 3. So on this one, it says specifically x is 4, y is 2, z is 3. You more times than just see this as x equals 4, y equals 2, and z equals 3. So those mean the same thing. So just going forward, we need to know that those mean the same. So when you're evaluating, we need to know what operation is going on between these variables. If you have x, y, z, those are all together. You got no operation in between. Those means that those are all being multiplied together. So you've got x times y times z. So that means my x is 4. So 4 times my y is 2 times my z is 3. Okay, so that is your x, y, z, and it's x, y, z plus 6. So multiply. Right here, 4 times 2 is 8. Drop everything else down. 8 times 3 is 24. Drop down your plus 6, and 24 plus 6 is 30. On B, I kind of have a little bit of a typo. This G isn't supposed to be here at all. So I'm just going to kind of mark out this G here, and so we're not supposed to have this G equals 1 either. Okay, so we are evaluating x squared plus z minus 3 for x equals 5 and z equals 4. So if you're kind of having this little helpful hint down here, it says if you're having difficulty replacing variables with numbers, first replace the variable with a set of parentheses, then insert the replacement number within the parentheses. So they turned our problem of x squared plus z minus 3 into this right here without any variables. They just put parentheses where variables need to be. And I like this because now that this was x squared, well, what is my x? My x is 5. So we're replacing 5 right here. Okay, same thing. This is z. What is z equal? Z equals 4. And so now this is plus 4. So if you're having trouble, wherever you see a variable, put parentheses, and that makes it a little bit easier to put things in. So order of operations, I'm going to write that over here. That's our please excuse my dear Aunt Sally. We have no parentheses, but I do have some exponents here. We got that 5 squared. So 5 squared simply means 5 times 5. 5 times 5 is 25. Bring everything else down. So plus 4 minus 3. Then you got to multiply and divide. Well, we don't have any multiplication or division, so skip that. And then lastly, add or subtract. Remember, you're adding and subtracting from left to right. So we have an addition first. So 25 plus 4 is 29. Drop down your minus 3. And 29 minus 3 gives me 26. Okay, we've got 2 more examples of evaluating. So, first one, you got 2 in parentheses x minus y. So, drop down your 2 parentheses. What does x represent? X is 6. So, we've got 6 minus, and then what is my y? My y is 3. So, use your order of operations. Please excuse my dear Aunt Sally. Start with parentheses. Do we have any parentheses? Yes, we do. In parentheses, you got 6 minus 3. So 6 minus 3 is 3. Well, now we only have one operation left, so it doesn't really matter about my order of operations. 2 times 3 is 6. Okay, on D, evaluate x minus 5y all over y. So notice here you've got y twice. That means I'm using this number of 5 twice when I'm evaluating. So x is 35. So you've got 35 minus, what's going on between this 5 and y? There's no operation, so it means that operation is multiply. So we've got 5 times my y is 5, so 5 times 5. And this is all over y, and y is again 5. So please excuse my dear Aunt Sally. You need to use those operations on the top. So on the top, we have no parentheses. We have no exponents, but I do have some multiplication and division. So we need to do that 5 times 5 first. So I've got 35 minus 5 times 5 gives me 25. It's all over 5. So now we need to subtract. That's going to give me 10. 35 minus 25 is 10. And so this little bar right here means to divide. 10 divided by 5 is 2. Okay, I was looking ahead on part E. Notice here that in your last lesson, we kind of went over what undefined means. We need to remember what undefined means. Undefined simply means that you have some number being divided by 0. And so that's the only difference here between choice A and choice B. You're still going to do your A plus B, your A minus B, your A times B. But when you get to your A divided by B, is it going to give you a number or is it undefined because we're dividing by 0? So let's just kind of go through these and see what we get. So no matter if it's A or B, when I do A plus B, they've already done this top bar here. So we're not even looking at that one there. We're looking at this one here. My A is 133 and my B is 0. So 133 plus 0, that's nice and easy. That's 133. Now we've got A minus B. My A is 133. My B is still 0. So 133 minus 0 is 133. Again, nice and easy. Then we got A times B. A is 133. B is 0. Well, 0 times anything is 0. And now we get to this A divided by B. So now we've got 133 for my A and my B is 0. That is my undefined that we were just talking about. So because of that, we need to select B and then put these numbers in these spots right here. If this was not dividing by 0, then we would click A and then you put the same answers in for A. Okay, so that's from my math lab and that's number 2. That's another one that a lot of people get tripped up on in my math lab just because they're trying to make it more complicated than it needs to be. All right, on to objective B. Objective B is identifying solutions for equations. So it says right here in objective A, we learn that a combination of operations on variables and numbers, should be numbers, is called an algebraic expression or simply an expression. Here's our new term. A mathematical statement that two expressions are equal, this is called an equation. We treat expressions and equations differently. An expression, all you can do, and I'll kind of put this over here, is simplify that. Or if they give you a number, you can evaluate. But with an equation, you can actually solve it, which I believe we're going to start doing in the next lesson or two. So the biggest difference is that equal sign. That's what this little helpful hint is saying. An equation contains equal sign while an expression does not. So you have an example of what an equation looks like. You've got an expression on this side, x plus 10. You've got an expression on this side, 10, but you have this magical equal sign right there in the middle. So right here, when an equation contains a variable, deciding which values of the variable make an equation a true statement is called solving an equation for the variable. A solution of the equation is a value for the variable that makes the equation a true statement. So because of this equal sign here, that means there's only a limited number of answers we can plug into this equation and it actually be true. For what we're going to be dealing with today that are all linear, there's literally one number that we can plug in, and that is it, which that's opposite of an expression, because an expression you can plug in any number you want because it doesn't have that equal sign. It doesn't have to equal anything. You can make it equal whatever it wants. So here in example 2, we're determining whether 6 is a solution of this equation. So you're wanting to know does x actually equal 6? So to determine that, plug this in. So we've got 4 times x, my x is 6, minus 3, and we want to know, does that equal 12? So, order of operations. We've got please excuse my dear Aunt Sally. Tells me parentheses first. So in the parentheses, we got 6 minus 3. That's 3. Bring down everything else. Bring down your 4. Bring down your equals. Bring down your 12. So now the only operation we have left is my 4 times 3, which is 12. So you've got 12 equals 12. Is that a true statement? Yes, it is. So determine whether 6 is a solution. It is a solution. So we will write, yes, 6 is a solution. Okay, and kind of notice here, when it equaled 12, I didn't do anything to that 12 on that equal sign. It just kind of followed me down. So you want to get it to where you got one number on each side, and then once you got that one number, it just needs to keep following you down until you're done. On B, determine whether 3 is a solution for the equation. So again, does x equal 3? That's what we're trying to find out. And my variable is not x in this problem, so we actually want to know, does m equal 3? So where I see both of these m's, I am plugging in that 3. So 5m, that means 5 times m, so we're going to go 5 times 3. Bring down your minus 9, your equals. Same thing here, 2m means 2 times m. M is still 3, so 2 times 3, and then plus 24. So I'm going to do one side at a time. So please excuse my dear Aunt Sally. For the left side, we need to multiply first. So 5 times 3 is 15. Bring down your minus 9. Then we are subtracting. So 15 minus 9 is going to give me 6. So that's what I have on one side. Bring this equal sign down. Now go to the other side. So on the other side, we've got 2 times 3 plus 24. So again, we need to multiply. So 2 times 3 is 6. Bring down your plus 24. Now the only operation I have is add. 6 plus 24 gives me 30. Does 6 equal 30? No, it does not. So I'm going to put a little line through that equal sign. That means does not equal. So 6 does not equal 30. So determine whether 3 is a solution. No, 3 is not a solution. Okay, so you're just plugging in, seeing if you get a true equation. When you get something like 12 equals 12, then yes, it's a solution. When you get something where a number does not equal another number, then that's no, it is not a solution. Determine which numbers in the set, 26, 40, and 20, are a solution of the equation. So in this one problem, we're checking 3 different numbers. Okay, so let's start with the first number it gives me, 26. This means where I see this variable of n, we're plugging in a 26. So 2n means 2 times n. So in this case, 2 times 26, now write the rest of this. Minus 30 equals 10. So order of operations tell me to multiply first. So 2 times 26 gives me 52. Drop down everything else. 52 minus 30 is 22. Does 22 equal 10? No, it does not. Move on to the next one, 40. So now in place of this n, now I'm placing in 40. So now I've got 2 times 40 minus 30. We want to know, does that equal 10? That's what we're looking at that one too. So multiplication first, 2 times 40 is 80. Drop down your minus 30. Your equals in 10. 80 minus 30 is 50. And again, 50 does not equal 10, so that is not a solution either. So let's see if 20 works. So now we're placing 20 in place of this n. So 2 times 20 minus 30 equals 10. Order of operations says to multiply first. So 2 times 20 gives me 40. Drop down your minus 30 and your equals 10. 40 minus 30 gives me 10. Does 10 equal 10? Oh, heck yes it does. So determine which numbers in the set. Only 20 is a solution from the set. All right, and then last objective in this lesson, objective C, we're going to translate phrases into variable expressions. So expressions, let's kind of review back. I want you to think, does that have an equal sign or does it not? No equal sign. Okay, that was our vocab today. If it has an equal sign, it's an equation. So what we're translating this into is expressions. That means no equal sign to be found. So to aid us in solving problems later, we practice translating verbal phrases of algebraic expression. Certain key words and phrases such as addition, subtraction, multiplication, or division are reviewed next. So you have a list here. When it says something like add, plus, added to, more than, increased by, total, those are your key words that we're using addition. Difference, minus, subtract, less than, decreased by, less, those are all your key words for subtraction. Product, times, multiply, multiplied by, of, double or tripled, those are your multiplication keywords. Quotient, divide, shared equally among us, never heard that one. Per, divided by, divided into, those are all keywords for division. So example 3, write an algebraic expression, use x to represent, in quotes, a number. So we have 7 increased by a number. So take this piece by piece. In words, 7, what does 7 mean? Well, that just means the number. You have increased by. What is increased by your key word for? That's right here. So that means addition. So plus a number, we're letting x represent a number, so x. So this is just 7 plus x. Okay, turn the page. We got a couple more of these examples. I'm not going to flip back and forth, but you need to keep these subtraction, multiplication, division keywords in mind for this next page. All right, B says 15 decreased by a number. So we've got 15. What does decreased by tell us to do? Decreased by means to subtract, and then you have a number. That is my x. So this one is 15 minus x. Okay, the product of 2 and a number. Well, this one actually kind of has 2 keywords. You've got product and of. So those were both on that chart for multiplication. So you kind of have an option on this one. You can either do 2 with a little dot x to mean 2 times x. But we learned at the beginning of this lesson that 2 times x is kind of shorthanded for just 2x. That's why we need to get comfortable using and seeing. So I'm going to write that as just 2x. And then the quotient means what? Quotient means to divide. So we got the quotient of a number and 5. Notice a number comes first, so it needs to be on top. So you've got x over 5. Okay, or I guess you could also write this. We haven't really used this bar very much, or maybe not even at all yet. You can just do x and then your division sign 5. Okay, but those do mean the same thing. Now E, our very last one, we're going to end with a tricky one. You've got 2 subtracted from a number. When you look at B, we have 15 decreased by a number. Notice it's in order. We've got 15, we've got minus, we've got x. It's right there, all in order the way you read it. So when you write this one here, it's very tempting And I'm going to write this in red because that's not what you want. It's very tempting to do 2 minus x. Since the 2 comes first, we're subtracting and then a number. But the order of these words will actually kind of be against us. This is not the correct answer. When you see this key word of from, that's kind of your starting point. It's from this number, and so that means that's got to come first. So since it's from a number, it's x. And then from this number, what are we doing? We are subtracting 2. So this one is x minus 2. Okay, so be careful with that from. And so that's what this helpful hint down here is kind of saying. It says, remember that the order is important when subtracting. Study the order of numbers and variables below. So your first phrase is kind of like that, is like B. A number decreased by 5, that's x minus 5. But on this one, when it has a number subtracted, that keyword from 5, 5 has to be the front, and then what are we doing to this 5? We're subtracting x from it, so it's 5 minus x. So that from, make sure you start with it. So that is all from this lesson. Rewind it, pause it as you need to.